Hello, my thoughtful teenagers, and welcome back to another episode of Grade 10 Maths with me, Miss Lambert. We are still on algebra, but for this lesson, we are going to be looking at how we can factorize a quadratic expression. So, as I said, we are looking at how to factorize a quadratic expression. But first, you must ask yourself, what is a quadratic expression? Let's read the definition together. A quadratic expression is an expression in x in which the square is the highest power. Let's go that once again. It says a quadratic expression is an expression in x in which the square is the highest power. Now here you can see the general form for a quadratic expression. It says ax squared plus bx plus c. Something I want you to remember. A, B, and C are all elements of Z. Now, what is Z? If you remember rational numbers, clearly you're going to remember that Z represents the group of integers. So, A, B, and C are elements of the group of integers. Let's continue. How do we factorize a quadratic? Now, what I'm going through here with you is one of the ways we can factorize a quadratic. Now, here you're going to see we have multiply A by C. That is why we call it the AC method. Now, when you multiply A by C, you need to find a pair of factors for AC that must be equal to B. Don't worry, we're going to go into this one bit at a time as we continue. Additionally, we can examine the trial and error method to ascertain the previous step, which is to get our pair of factors which will equate to B. Then we simply factorize by using the grouping method. And only recently we looked at how we can factorize using grouping. Now let's continue to see how we can now factorize a quadratic expression. Now here we have the general form of a quadratic expression, which is x squared plus bx plus c. Now when we multiply a by c, we will get some number. When we get that number, we want two of its factors that will give us the value of b. Or in this case, we have p plus q. Sum of the two factors must equal p plus q. Now, when we would have rewritten our expression like it is in the third step, we then factorize using the grouping method. So now that you have all that information, let's throw some figures in there and have a better understanding of how we can factorize. Now, here we have the quadratic expression that says x squared plus 7x plus 12. The value of b, or p plus q, is 7, because we can see that from our equation. Now, ac is equal to the value of a multiplied by the value of c. In this case, the value of a is the coefficient of x squared. And once there is no visible coefficient, we know that the coefficient is equal to what? Yes, 1. So now that we know that the coefficient of x squared is equal to 1, we can multiply that by the value for c, which will give us 1 multiplied by 12. Now remember, we are working based on the guideline that was given. So once we would have found AC, we then write all the factors of AC. So here you can see I have the factors of AC, which is 1 and 12, 6 and 2, and 4 and 3. Now remember, the reason we need to examine all of the factors is that we want to know which pair of factor, when we add them, p plus q, will give us the value for b. Now you need to choose the pair of factor that when you sum them, you get b or p plus q. Now let's take a look here. We have the same quadratic expression, x squared plus 7x plus 12. But when we sum 4 plus 3, we're getting the value for b, which is 7. So our two factors that we're going to use is 4 and 3. Why? Because 4 multiplied by 3 will give you, yes, you would have guessed right, our c value, or our AC value rather. Next, we factorize by grouping. So we group the first two and the last two, and we factorize. And I know that you can remember how to factorize. So when you look here, you're going to see that we look for the common factor in each pair. Once we would have done that, we factorize, which is to divide. So once we do that, here we will have our answer. So when x squared plus 7x plus 12 is factorized, we will get x plus 3 into x plus 4. Now we're not done. Let's take a look at yet another example. So this example says that x squared plus 3x minus 10. We have x squared plus 3x minus 10. Now when we multiply here, we're going to have AC is equal to negative 10. Now here is when signs come into play, and you need to be very careful when you are dealing with signs. So what we go ahead and do is list the factors of 10. So here we have 1 and 10, 2 and 5, and that's basically it. But remember, we are summing and our AC value is negative. So we need to consider a negative sign in either one of the factors in order to give us a negative answer. But when we need to ascertain the value for B, that is positive. So then we need to do some testing, what I call trial and error. So here, if I am to add negative 1 to 10, I'm going to get 9. If I'm to add negative 2 to 5, I'm going to get 3. Now, here you can see that I would have already found my pair of factors. So I can rewrite my quadratic using the pair of factors. So here I can have x squared minus 2x plus 5x minus 10. So from this, I will now factorize by grouping. Factorize by grouping, I look for my common factor, which would be x, and I factor that out, which gives me x minus 2 in bracket. On the other hand, I will look for my common numeric factor, which would be 5. And when I factor that out, I'm going to have x minus 2. So now that that is done, we can write this in a simpler term. So what is outside of the bracket is written together, and then we rewrite what is inside of both brackets once. And there you would have factorized another quadratic. Here we have yet another example. X squared minus 4x minus 21. So here I have AC yet again to be a negative value. But then I need to look at my factors for 21. Now when I list all of my factors, I can see that in order to get a negative 4, I will need to use one of my value to be negative and one to be positive. But my larger value must be negative in order for me to get my negative 4, as you see here. So we can look and see that if we multiply 7 by 3, we'll get 21. But if I add negative 7 to 3, I will get negative 4. So now that I know my factors, I can rewrite my quadratic. X squared minus 7x plus 3x minus 21. Factorized by grouping, I have x into x minus 7, and I have 3 into x minus 7. Rewrite this in a simpler form. X plus 3 is into x minus 7. And there you have it, all of your quadratics simplified by factorization. So we looked at how you can factorize a quadratic expression. Let's recap what we completed on this lesson. We said that a quadratic expression is an expression in x where the square is the highest power. And the general form is represented as ax squared plus bx plus c, where a, b, and c are all elements of integers. Now, how do we factorize? We multiply the value of a, which is the coefficient for x squared, by c, which is our constant value. And once we would have done that, we need to choose a pair of factors that will help us to get b. But what is b? b is that value that you get when you sum the two factors. Then we rewrite our equation in the form x squared plus px plus qx plus c. We factorize using the method of grouping. And that is how you factorize quadratic expressions. Now, remember, we can never leave without additional work. So what I would like you to do for me, reference Mathematics, a Complete Course with CXE Question, Volume 2, Exercise 13J, which can be found on page 739. And I want you to practice as many problems as possible. There are 82 problems in this exercise. If you can do all, perfect. But if not, try to do as many as you can. So there you have it, my thoughtful teenagers. Our lesson on factorizing quadratic expressions using what we often call the AC method. Please remember to practice, 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 because I would like you to be pros when it comes to solving quadratic expressions using the AC method. See you next time. Bye-bye.